everybody. This lesson is about half-angle identities. Half-angle identities are useful in trig, but they don't become super useful until you get to Calc 2. This lesson is to expose you to them. Due to our lack of time, I don't expect you to master these. There won't be any proving identities or solving equations with them, but they will show back up in Calc 2 because you need them to integrate, which I know you don't know what that means right now, but they're super important for that. So this is exposure. I want you to try the assignment, do your best, and it's not hard, it's just the useful part about it doesn't come up until Calc 2. Okay, so our half-angle identities is sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2. Okay, that's the first one. Put that one in the first box. The second one is cosine of theta over 2 equals plus or minus the square root of 1 plus cosine theta over 2. And then the last one, and I don't even think I used this one in Calc 2, maybe I did, it's been a long time, is tangent of theta over 2 equals sine theta over 1 plus cosine theta. Okay, so if we are looking at example 1, it says find the exact value of cosine 15. Now here's kind of the tricky part that kind of confuses kids, is we do not want to write cosine of 15 over 2. That is absolutely not what we want, because theta over 2, actually we're using this one, theta over 2, this whole quantity needs to be 15 degrees. So if theta over 2 needs to be equal to 15 degrees, multiply both sides by 2, theta actually needs to be 30, which is helpful because I know a lot about 30-degree triangles. So we're going to look at cosine of 30 divided by 2, which is the same thing as cosine of 15 degrees, equals plus or minus the square root of 1 plus cosine theta divided by 2. Which, what is my theta? What did I plug in for theta? If I look back here at my formula, I plugged 30 in for my theta. So I'm going to go back here, erase this theta, and plug in 30. Okay, second hard part is this plus or minus. It's not like the quadratic formula. You don't always have a positive answer and a negative answer. You have to kind of think, okay, cosine of 15 degrees, that's going to be in the first quadrant. All students take calculus. Right here in the first quadrant, cosine is positive. So it's going to be positive. It's not going to be negative. So I'm going to quit writing plus or minus and just write positive. This plus or minus in the formula means you need to check to see if it's positive or negative. Okay, so from here we have the square root of 1 plus cosine 30 divided by 2. So if I do cosine 30, I'm going to go back up to this triangle over here, 30. Across from 30 is 1. Across from 60 is root 3. Hypotenuse is 2. Cosine is adjacent over hypotenuse. So I have the square root of 1 plus the adjacent is the square root of 3. Hypotenuse is 2 all over 2. And we're not done because it's not really simplified. So I'm going to keep going. So it equals the square root of, I'm going to go ahead and divide both of these quantities by 2. 1/2 plus the square root of 3 over 4. Now I need to get a common denominator and combine them. So I'm going to multiply this quantity by 2 over 2. So that gives me the square root of 2 over 4 plus the square root of 3 over 4, which equals the square root of 2 plus the square root of 3 all over 4. And that's almost everything I can do. The last thing that I can do is I can go ahead and take that square root of 4 in the denominator. So that leaves me with the square root of 2 plus the square root of 3 all over 2. And to be honest, that is an ugly answer. The easier way to do it would be to do the difference identity and do cosine of 45 minus cosine of 30. And the answer will be prettier. They come out to be the same number, but yeah, this is ugly. The main reason you need to learn this is for Calc 2. So I'm going to do one more example on the next video, and I will take questions over this too. So, all right, here we go.